I'm Fuzil Ahmed, Data Science and Business Analytics intern at the Sparks Foundation. My task is stock market prediction using numerical analysis and textual analysis. Our objective here is to create a hybrid model for stock price and performance prediction using numerical analysis of historical stock price and sentimental analysis of the news headlines. S&P BSE Sensex stock is the stock we are using to analyze and predict. The historical stock prices are being obtained from the Yahoo Finance website. And for our news headlines, we will be taking the Times of India's news headlines in this particular CSV file. Now let's get into it. First off, we will be importing the required libraries. NumPy, Pandas, Matplotlib, Seaborn, Datetime, other general libraries. Then the libraries required for textual analysis, the libraries required for numerical analysis, and the libraries required for prediction. Then we will be downloading our data set from our website using the data reader function from Pandas data reader. Here BSE SN refers to S&P BSE Sensex stock from the Yahoo website from January 2017 to September 2022. After that, we will be filtering the warnings. Data head will give us the first 5 stocks from our dataset which we have previously extracted from the Yahoo Finance website. And data tail will give us the last 5 stocks. After which we will be converting our obtained file into a CSV file. Next up, we will be importing the stock market price dataset into the stock using the read CSV function of the pandas library. Similarly, the procedure will be followed for the news headline CSV, storing it into the news. The news.head will give us the first 5 news headlines, and the stock.head will give us the first 5 stocks. Stock.tail gives us the last 5, and stock.sample will give us randomly selected 10 stocks from the stock dataset. Similarly for the news.head and tail.head and the news.sample. After which we will be using the shape attribute in Pandas, which enables us to get the shape of a data frame. So for example, the shape of the stock price dataset is 1404,7. This implies that the data frame is made up of 1404 rows and 7 columns. We'll be performing pre-processing of data, that is the ETL process, removal of duplicate values and null values. So we check the shape of our news dataset, after which we realize that we do not require the data category column, so we drop it. And then we rename the columns here of publish date to date and the headline text to news. And then we will be using the info method. The info method prints the information about the data frame. So this is the information about the news dataset and the stock dataset. We can see the data type of date in news dataset is integer, whereas in the stock dataset it is an object. So first we will convert them into objects and then to datetime. This is done to ensure there is format as we may need to merge them further on. So first we convert them to the objects and then to datetime. So this is the stock dataset converted in datetime, and this is the news dataset converted in datetime. So just to look whether they can be merged or not, let's perform a temporary merge. We perform the temporary merge on both the datasets, and we can see that the datasets have been merged. And then we check whether there is any null values in the temporary merge or the datasets. After this, we will check for duplicate values. Here we see that we have a enormous amount of duplicate values. So what do we do is to find the non-duplicate values, the total values minus the duplicate values. Now we must have only non-duplicate values. So we can do this by using the function drop duplicates. And now we can check it and we have zero duplicates. So after which we will be applying a function to remove the special characters from the news text. So this function will be using the alpha num method, which returns true if all the characters in the strings are after a numerical. So for example, we'll be applying it on the first index. Here we just have a semicolon, which is a special character. Hence, after applying our function special remove special chars, we can see that the semicolon is gone. And for another example, here we have a question mark, and after applying the function, we get rid of it. And then we will, after applying the remove function, we'll just check a before and after, and then we will group all the headlines for a particular day. So by using the group by function. Now we can notice that the group text para is repeating itself. Also, the indexing after 25 is inconsistent as it directly jumps to 52. So now let us just check the paragraph for the first index. So we check for this first index and the 10th index. Uh, Here we can clearly observe that the entire paragraph is repeating, so we will need to drop the duplicates and reset the index. So we drop the duplicates and then we reset the index, after which we can see we obtain the data set for the headlines with no duplicate values, no null values, and after removal of all the special characters. Hence, our number of rows is being reduced to 7,717. Before we move on to textual dataset pre-processing, we must understand what polarity and subjectivity is. Polarity refers to the strength of an opinion. It could be either positive, negative, or neutral. If something has a strong positive or feeling or emotion associated with it, such as trust or love, this will have a certain orientation towards all other aspects of the object's existence. Same goes with negative polarities. A good example would be, I don't think I'll buy this item because my previous experience with this item wasn't so good. And subjectivity would refer to the degree to which a person is personally involved with an object. Here, what matters most is the personal connection and individual experience with that particular object, which may or may not be different from someone else's point of view. For example, I'm very happy with the new smartphone I bought because it has the highest performance on the market. Now, we make use of sentiment analysis tools to distinguish between polarity and subjectivity in order to analyze a user's opinion correctly. An opinion can have a high degree of subjectivity if it's expressed as a positive or a negative personal experience, whereas a lower degree may indicate someone else's point of view. So we have two functions for getting the subjectivity and polarity, after which we will be applying these functions to the headlines dataset. And then we plot a graph here for the polarity score, which is shown below, and also a graph for the subjectivity score. Then we will be performing the sentiment analysis to find the polarity source. Here we find four different polarity scores, that is the compound, negative, neutral, and positive. After which we can see that the news headlines have increased to 8 columns. That is, which is nothing but the subjectivity, polarity, the compounded polarity, negative polarity, neutral polarity, and positive polarity with their subsequent values. Now we perform the numerical and historical dataset preprocessing. Um, we check the length of the stock, which is 1404, and the info. We just check for the null values, and if there are any null values, we drop these null values. After which we check the length again, which is same as before, indicating that we did not have any null values to begin with. And then in the end, we just describe the current state of the stock data set. Move on to data visualization. Here we've plotted a graph for the closing price of our stock. The closing price is the price of a security stock at the end of day's business in a financial market. After which we understand what is plotting moving average. So in finance, a moving average is a stock indicator which is commonly used for technical analysis. The reason for calculating the moving average is to help smooth out the price data by creating a constantly updated average price. So this is being done to determine the support and the resistance levels. Here, the longer period for moving average, the greater the lag. So, a 200-day moving average will have much greater lag than a 20-day moving average because it contains the price for the past 200 days. So, what is rolling means and why is it used? So, typically, we use the rolling mean to smooth out the data series. This is usually used to identify the long-term trends. This can be calculated by averaging a group of observations of a variable of interest over a specified period of time. And lastly, what is the rolling standard deviation? This is nothing but a measure of market volatility. It makes no predictions of the market direction, but it can serve as a confirming indicator. Now we'll just be plotting the graph for the moving average. Here we can see the closing price history, the rolling mean, and the standard deviation. After which, we also plot a graph for the returns of our particular stock. The return is nothing but a change in price of an asset, investment, or a project over time, which may be represented in price change or percentage change. You can give a positive return, which represents a profit, while a negative return marks a loss. Here we have the return graph which is being plotted for our stock, which is S&P BSE Sensex. Make the prediction model for forecasting purposes in the time series analysis. We will require a stationary time series for better prediction. So the first step to work on is to make a time series stationary. Various tests can be performed for stationarity, such as the KPSS, Phillips-Perron, and the augmented Dickey-Fuller. The augmented Dickey-Fuller is a statistical significance test, which means the test will give us results in the hypothesis test with null and alternative hypothesis. As a result, we will have a p-value from which we will need to make inferences about the time series, whether it is stationary or not. Before we move on, we need to understand what a stationary and a non-stationary time series is. So, a stationary time series has statistical properties or movements that do not vary with time. Conversely, non-stationarity is a status of a time series whose statistical properties are changing through time. Here we are defining our stationary function, which is the Dickey-Fuller test, and then we will be splitting our data into training and test data. After applying the stationary test, we will visualize it. Here we can see the graph of the original rolling mean and the rolling standard deviation. And the result of the Dickey-Fuller test conclude that we have weak evidence against the null hypothesis. Hence, the time series is still non-stationary. So, to eliminate this, we in the cell 90, we see the training and test log is similar, but improvements can be made by dropping the null values. So we will be dropping the null values over here, and after which we will see the rolling and standard deviation. But still, we see that we have weak evidence against the null hypothesis, and the time series is still non-stationary. So we will in the cell 93, we find the training log difference, which is nothing but the training log minus the MAV. You may ask what the MAV is. Here we can see that is nothing but the rolling means value we're storing in the MAV. Hence, after performing this, we run this test stationary function on which we get the results of the Dickey-Fuller test. Now we have strong evidence against the null hypothesis, which should reject the null hypothesis. Hence, the data is now stationary. Now we'll be training our prediction model. We'll be making use of ARIMA. ARIMA is abbreviated for Autoregressive Integration Moving Average. It is nothing but a class of models that demonstrates a given time series based on its previous values. So first you'll need to install the PMD ARIMA using the pip install PMD ARIMA, after which we will be creating our model using the AutoArima function, and given below is the data frames for our prediction model, which has the total fit time of 2.282 seconds. Now we will be plotting a graph or a chart for the BSESN stock price prediction. Here in the x-axis we represent the time and y-axis represents the actual stock price. We have a visualization of our prediction model. Here the lime green line depicts the prediction and the yellow line is the actual stock pricing in the specified time period. We can observe how close the prediction and the actual pricing, which indicates that our model is highly efficient. Now we will determine the root mean squared value of our prediction model, which is 0.073. Now we will be using different models to determine the best performing model using root mean squared error as our testing parameter. So first we will merge the numerical and textual data, after which we will be creating a data set for the model training, and then we will normalize our data. This is being done using the min-max scalar, and finally we will be splitting our data into the training data and the test data. After that, we will be making use of different models and deploying them and checking their mean squared error. First up, we will be using the random forest regressor model, then the decision tree regressor model with its mean squared error, then the ADA boost regressor, next up the LGBM regressor, but first we will need to install this library, and then the XGBoost regressor, and then finally we can conclude, depending upon their mean squared error as a testing parameter, we can say the error booster regressor is the best performing model. Thank you. I hope I've provided you with meaningful insights into the stock market with the completion of my task.